Thank you. Good afternoon. As I know that I am the last one which is standing between you and coffee, I try to be short. Okay, so I first describe a little bit about our company. So we are a spin-off from the university as well, and we focus mainly on the simulations, and we do the air traffic management simulations, like of the large air traffic. And we do also the simulations of the drones. So for us, the integration of the drones into the shared airspace is something natural. And beside this, we also have like our own drones, which you can see on the lower picture. So we are certified drone operator, and we use, let's say, the experience from flying the drones for different kind of industrial work to actually improve our simulation and make it like more realistic. So we actually, it's not something like that. It's like university simulation, and we are not attached to the real world. So we have like the drone, so we actually know what does it mean to fly with the drone. Within this project, we provide mainly our fast time simulation, and the question is, let's say, why to make fast time simulations if we are able to fly with the real drone? So you will see it in a moment. Let's say to fly the real drones is like really hard and challenging, and it needs a lot of different kind of experience. But the fast time simulation can look more into the future, because right now we will fly with one drone, few drones, maybe 10 drones. But we need to know what will happen when we will have hundreds drones, thousands drones, or maybe the prediction is that there will be flying like 100 drones within the airspace, and we need to know what will happen. What are the limits? How many drones can fit into the airspace? Like what will be the problems? What will be the bottlenecks? And this is exactly where we can employ the fast time simulation. So within the fast time simulation, we can simulate different kind of drones, different kind of traffic. We can develop different kind of scenarios, and we can run it, and we can run hundreds and thousands of these simulations, and we can find out like what are the problems and how to resolve them. Okay, so I will show you this picture once again. I'm sorry for the wrong circles, as I can see. Actually, I don't want to circle any of them. We are like original, like that gray box in the middle, but sorry about it. But in general, I don't want to encircle any of them, because the goal of our simulation is like twofold. First is, let's say, to make this big scale simulation where we can, let's say, emulate the whole environment and go with really a wild number of drones. But the second purpose within this project is actually to integrate with other partners, for example, with Helico C2C, and actually test the scalability of their software. So they can fly a few real drones, and they are connecting within the scenario. They can be like heterogeneous. So a few days or weeks ago, there was like the experiment with actually operating the drones in different countries at the same time, which is, let's say, something what don't happen often. But we can feed into the system some new drones, like the virtual ones, but from the point of the C2C, they will not distinguish it if they are like the real world or emulated virtual ones. And we can test, let's say, all the channels, all the processes and everything. So we can emulate the drones. The vice versa, we can emulate, let's say, the C2C to add several C2Cs and test the functionality of the use-based service providers and so on. So we can, let's say, emulate different parts of the whole ecosystem to make the stress test and to make the evaluation and validation of going large scale within different kind of components. And the last slide is, so this is the example, let's say, how this simulation looks like. So for example, this is the simulation from the location of the Athens in Greece. So we can actually see that the simulation like take into consideration different kind of information. So you can see that you take the geographic information. So you have the surface of the terrain, you have the buildings. So you have this kind of information which has like direct impact to the flights of the drone. drones, because drones are flying like near to the ground, so it's like really important to have this kind of information. But also because they are flying, you need the information about the airspace. So you can see some kind of restricted zones, like different colors means the different meanings of the drone. So some are because it's restricted within the city center, some of the are zones around the airports and so on. And you integrate everything within the simulation, and then you are fit in with aircrafts. You can use the historical traffic if it exists. For example, some manned flights which are flying within the area, or you can generate by virtual traffic generators to generate thousands of flights of different kind of drones, different kind of missions, different kind of traffic. And you can run all this together and evaluate what are the impacts and what are the metrics. So I think that this is everything in a shortcut, and we can have a discussion during the coffee break. Thank you very much.